This is lesson 12, and we're talking about compound interest. And compound interest usually deals with money. So compound interest is a good example of an exponential equation. So if you have a bank account or a credit card, you need to think about interest, and interest is a good example of exponential growth. Or if you buy a car, it loses value over time, which is an example of exponential decay. And there are two basic equations that you will use to determine the amount of money that you have based on the amount of investing time and the interest rate. So the exponential growth equation you see below is y equals c 1 plus r raised to the t. And the exponential decay equation looks very, very similar. Instead of adding r, you're going to subtract r. The y value is your ending amount, or the amount that you're going to have after a certain amount of time. The c represents the starting amount. The r is your rate. It's usually given as a percent, but you have to change it to a decimal by moving the decimal 2 places to the left. And then r will be time, and that will be in years. So let's look at some examples. When you give an example, there are certain steps that you're going to have to take. So you first decide if the problem is growth or decay, and then pick the right formula. And then decide what variables you're given and see what variables you need to solve for. You're going to plug those variables into the equation and solve. And then the last thing you want to do is interpret your results and make sure that it makes sense. So here's an example. You deposit $500 in an account that pays 4% interest compounded yearly. What is the balance after 10 years? So first you have to decide whether it's growth or decay. Well, the money will increase, hopefully, when you put it in a bank account, so therefore it'll be exponential growth. So here's the exponential growth equation. The y is your ending amount. That's the value we don't know. C is the initial amount where you deposited $500. The rate is given as 4%, so you have to move the decimal 2 places to the left. So it'll be 0.04, because you always use the decimal in the equation. And the time that they want you to find out what the balance is 10 years. Once you've decided what your variables are, you're just going to plug them into your equation. And then you can just solve this equation. You can actually put this right into your equation, into your calculator, using parentheses. And when you want to raise something to the 10th power, you're just going to use that little, it looks like an upside down V on your calculator, and that's how you're going to raise something to a power. If you're not sure how to do that, just let us know, and we'll be happy to help you with that. So if you put this in your calculator, you get $740.12. So that means that that's the amount of money that you'll have in your account after 10 years. Here's another example. John buys a car for $33,000. His car immediately starts depreciating, losing 25% of its value every year. How much will the car be worth in 5 years? So now the car is losing value, so this will be an example of exponential decay. Here is the decay equation. I don't know what the value is after 5 years, so I don't know the ending value. But the beginning value, or the starting value, was $33,000. The rate they gave you was 25%, so I have to change that to a decimal, which is 0.25. And they want to know what its worth will be in 5 years. Let's plug those values into the equation. And now, once again, just put this into your calculator, and you'll find out that the car will be worth $7,831.05 in 5 years. Now, this example is just a little bit different than the previous two. How much money did Charlie deposit in his account 4 years ago if it pays 6% interest, and he now has $12,800 in the account? So they're still talking about depositing money in an account, so money will still increase, so it's still exponential growth. Here's the exponential growth equation. But now I know the ending value. I know that I have $12,800, or Charlie does, in the account now. What I don't know is how much money Charlie deposited initially, so I don't know the starting amount. The interest is 6%, which as a decimal would be 0.06, and the time is 4 years. So now I'm going to plug all of that into the equation, and so this looks a little bit different than the other two. So let's see how to solve this equation. So let's take the expression 1.06 raised to the 4th power and put that in our calculator and simplify it, and let's round to 3 decimal places. Well, now I need to solve for c. So to get c alone, I'm going to divide by 1.262. Whatever I do to the right side of the equation, I have to do to the left side of the equation. My 1.262 will cancel out, leaving c alone. And if I put this into my calculator, I'll find out that I have 10,142.63, which means that's the amount of money that Charlie deposited in his account 4 years ago. So if you have any questions, let us know.